Now let's take a look at example 1. So example 1 states, earlier you were given a problem about Janet and the flowering crabapple tree. She needs to figure out the height of the tree at the end of 6 weeks, given that it grows 6 inches a week. How can she figure this out? Well, we can write an equation. So first let's write down the given information. The height of the tree increases 6 inches in 1 week. Well, that's identifying for us that our change in height in comparison to time is 6 over 1. So what that's doing for us is it's giving us our slope, where we're looking at our change in time, our change in height, which is our y value, over time, which is our x value. Well, we increase 6 inches every 1 week. And 6 divided by 1 is just 6. So that is our slope. From there, it says the original height of the tree was 24 inches. Well, that means at a time of 0, we were at a height of 24 inches. So this is giving us our y-intercept. So we can get this equation of y equals 6x plus 24. Now, the next part of this problem says, well, what's the height of the tree going to be at the end of 6 weeks? Well, x is representing our time in weeks. So to figure out what is the height in 6 weeks, we need to plug 6 in for x. Well, 6 times 6 is 36. Adding 24 to that, and we get 60. So we know the tree will be 60 inches tall at the end of 6 weeks. Next, let's take a look at example 2. Example 2 says to write the equation of the line that has a slope of 4 and it crosses the y-axis at the point 0, -3. So it's telling us our y-intercept is -3. So it's giving us all the information we need to write an equation. Remember, our equation is y equals mx plus b, where m is our slope, so plugging that in, which is 4, and b is our y-intercept, which is a -3. So you could say y equals 4x plus a -3, or you could just say y equals 4x minus 3. All right, not much work for example 2. Let's take a look at example 3. It says write an equation in the slope-intercept form to model the values in the given table. So I'm going to take a moment and copy the table down as they have written in example 3. All right. Now, there's a couple of ways you can approach this. You could look at this and say, well, one of my points, 0, 6, when x is 0, that's always telling us where the y-intercept is. So you could say, hey, look it, here is my y-intercept. This is where it crosses the y-axis. And you could use that information, and then you can find your slope that way. And then you can plug all of that into your slope-intercept form. Or you could approach this like we did that one problem earlier in this concept where we were given 2 points. Okay, so write the equation where it passes through 2 points. So we went through a problem earlier in this lesson where it passed through the points 2, 6, and 4, -6. And we were able to find slope and y-intercept just given 2 points from the graph. And so you could go about it that way as well. So know that in example 3, there's kind of a variety of ways you could approach this problem and still get to the same answer in the end. So just be mindful that maybe your method is not the exact same as mine, but you still get the same result, that's okay. So in this problem, we're given the y-intercept in the table because anytime x is 0, that value of y is then where it's crossing the y-axis. So we know our value of b. We know b is equal to 6 in this slope-intercept form of y equals mx plus b. Now our goal is to find slope. To find slope, I'm going to use the slope equation, y2 minus y1 over x2 minus x1. You could, because you're given a table here, you could graph these points and then count out your distance of rise over run if you like to do it that way as well. Now we're given a lot of points here. So in my slope equation, it says y2 and y1 and x2 and x1 referring to point 1 and point 2. But we have a lot of points here. So you can choose any 2 points from the table. It does not make a difference, I promise. You can choose any 2 points from the table. I like to deal with smaller numbers, so I'm going to choose the point 1, 1. And then I'm going to choose the point 2, -4. All right. From here, I'm going to label them as x1, y1, and x2, y2. Just so I know which point is number 1 and which point is number 2. Now I'm going to calculate my slope. y2, which is -4, minus y1, which is 1. x2, which is 2, minus x1, which is 1. -4 minus 1 is -5. 2 minus 1 is 1. And -5 divided by 1 is just -5. So I found my slope from the table. I found my y-intercept from the table, which was 6. And I found my slope by pulling 2 points from the table, using the slope formula, and I got -5. Putting those pieces together, I get the equation -5x plus 6. And you can see here that the textbook actually even did it a little bit different than I did as well. And so their method is just as good if you want to see another way of approaching the problem.